Alright, so this is a video to review crisscrossing. We have two types of iron. We have iron 2 and iron 3, and they're forming iron oxides with the different oxidation numbers of the iron. So here I have iron 2. I know it's iron 2 because there's a Roman numeral 2. The Roman numeral tells me how many electrons the iron is losing. In this case, it's losing 2. So I'm going to have iron losing 2 electrons. And oxygen has a negative 2 because if you recall, it's in group 16. That means it has 6 valence electrons. It needs 2 more because 6 plus 2 is 8. So it needs to get 2 more electrons. Iron is losing 2. I'm going to crisscross these two. The 2 goes there and the 2 goes there. Remember, we are crisscrossing the charges so that we can get a neutral ionic compound. So I would get iron 2, oxygen 2, and I can further reduce this to FeO. So I have iron 2 oxide. Now I'm going to do the same thing with iron 3. Iron 3 has its Fe3+. Oxygen is still negative 2. So this one's losing 3 electrons. That one's accepting 2 electrons. So I'm going to have to crisscross these. The 2 goes here. The 3 goes there. So I end up with iron with 2 irons and 3 oxygens. That's iron 3 oxide. Let me do it with... Okay. So I have iron and has 3 positives. Oxygen has 2 negatives. So this one and this one cancel out. This one and this one cancel out. But this one still has an extra. So I'm going to get another oxygen. So this one and this one cancel out, but now this oxygen still has one. So I'm going to get another iron. Now these are cancelled out, so the oxygens are cancelled out, but I still have one more iron. So then this cancels that, and that cancels that. So I'm left with 2 irons and 3 oxygens. And what we're doing here is the same thing we're doing here with the crisscrossing, but the crisscrossing allows me to do it without having all that diagram.